Hey guys, and welcome back. Today we're going to be talking about solving equations in the form x cubed equals p. So we have a new vocabulary word that we are incorporating, but the same type of skill is going on as the previous lesson. So our learning target is to solve equations with cube roots and square roots. Okay, we're going to study what that means to cube, and it's going to be similar to our definition for square. Our success criteria today is I can simplify the first four perfect cubes. Okay, so that should be reminding you what we studied with perfect squares. There's going to be something called perfect cubes. They're going to be very closely related. We're going to solve equations with not perfect cubes. We're going to solve equations with cube roots. So just like the previous lesson, we solved equations using square roots, we're going to use cube roots now. And lastly, we're going to solve real world problems with these cube roots. So let's take a look at the key idea here. And if you can tell, the slide from today looks just like the previous lesson slide. Okay, so let's think about what a perfect cube is. A number that is a cube of an integer. So we only really have to memorize the first four perfect cubes, but I'm going to list out as many perfect cubes as I can on this page for you guys. Let's just start with 1. Okay, so 1 cubed, that really is 1 times 1 times 1, which is equal to 1. The rest of them, the other 4, okay, so 1 is one of the perfect cubes. And really, 1 is going to be a perfect everything. Okay, so 1 was a perfect square, and 1 is also a perfect cube. But then we also have more lists of perfect cubes. Okay, so 2 cubed, the word 2 cubed, as we say it, would be 2 to the third power. Okay, when we think about the word cubed, I want you to think of a power of 3. Think of like a square has 2 dimensions. It has a length and it has a width. 2-dimensional. So that is why we have a power of 2. With a cube, I'm going to do my best to draw a cube here for you guys. Really all I do is I draw 2 squares, one kind of offset from the other, and then I connect their vertices to make a cube. This has 3 dimensions. We have a length, we have width, we also have a depth. Okay, so that's 3 dimensions, which is why this is going to have a power of 3. So just like we related the word square to a power of 2, we're going to relate the word cube to a power of 3. Okay, so when we have 3 cubed, that's really 3 to the third power, which is 3 times 3 times 3. If you type that in your calculator, you get 27. 4 cubed is going to be 64. Okay, and we can also cube negative numbers as well. Okay, you see at the bottom here, 2 cubed, that's going to be negative 2 times negative 2 times negative 2. And whenever we cube a number, if you remember from the last lesson, when you square a number, all your answers become positive, whether they're negative or positive. But in this case, because we have 3 numbers now, a negative times a negative is going to be a positive. And then when we take that positive times the negative, that's going to result in a negative number. So when we cube something, whatever you cube, the answer is going to be the same sign as the original number that you cubed. But I want you to relate the word cube as being an inverse of cube rooting, just like square was an inverse of square rooting. So if you take the number 3 and you cube it, so you raise 3 to the third power, you get 27. That's 3 times 3 times 3. 3 times 3 is 9. 9 times another 3 is 27. Then we can go the other way around, take 27, cube root it. Okay, so that's the cube root of 27. You get back to the original number that you cubed, which was 3. Again, inverse operations. We're going to undo cubes with a cube root. Same kind of idea here, only think about the cube root symbol as being exactly the same thing as a square root symbol, only you have to write the little 3 up there. Okay, now a square root, you can write the little 2 if you want. It sits on top of the tail. We just don't write it because it's the first root you can take. There's no such thing as a 1 root. Okay? You can only start at taking the second root, which is the square root. Okay? So we just assume that if you don't write it, that really there's a 2 there. Okay? Which is why we write a 3 in the little tail for the cube root. If you don't write the 3, I'm going to assume it's a square root. So you have to write that little 3 in there, or else I will be thinking it is a square root. So now I'm going to take the same idea from yesterday, where we had x squared equals p, and we're going to apply that same kind of idea to x cubed equals p. So I have here to solve x cubed is equal to 25, and I have the steps written out just like I did on our previous lesson. So I'm going to rewrite our equation. X cubed is equal to 125. It says take the cube root of each side as our second step. So just like we wrote a square root symbol on each side of the equation, to undo that cube, you have to cube root each side of the equation. Please make sure you write that little 3 in the tail. So the cube and the cube root goes away. We just have x left over. And now I have to figure out what times itself twice, 2 more times I should say, is equal to 125. Okay, so on this slide, let's make a list of some more perfect cubes, okay? Because on this slide, we had 8, 27, and 64. We had those. Okay, so let's make a couple more perfect cubes. Oop, not the first example yet. Okay, so I have 1 cubed is 1. 2 cubed, if you do 2 times 2, that's 4. Times another 2 is 8. 3 cubed, 3 times 3 is 9. Times another 3 is 27. 4 cubed, 4 times 4 is 16. Times another 4 is 64. 5 cubed, 5 times 5 is 25. Times another 5 is 125. So there we go. I can see now that relationship between 125 and the cube of 5. That means the square root of 125 is 5. So I would say x is 5. Now the difference between this lesson, another difference I should say, between this lesson and last lesson is we don't need to use the plus or minus symbol. As we discussed earlier in the key concept, the square root of a number is going to match the sign of the number that you're originally square rooting, because you have 3 numbers when you cube. So we need to make sure that the signs actually match. So since 125 is positive, then that means the answer will also be positive. This is specifically for cube rooting. When you square root, make sure you include both the positive and the negative versions. I can also check my work by plugging into the original equation. So I'm going to plug in 5 in for x cubed. Okay, so we had x cubed is equal to 125. Really, that's 5 cubed is equal to 125. 5 times 5, that's 25. Times another 5, that's, 125. So 5 cubed is 125. If I were to try to do negative 5 cubed, so if you make the mistake and you want to check your work and you want to see if you should include the negative version, just cube it. So negative 5 cubed is really negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is positive 25. Positive 25 times a negative 5 is going to be negative 125. Well, negative 125 is not the same as positive 125. So negative 5 is not one of the answers to this equation. So let's give this a try in the first example. So just like the previous lesson, we're going to solve these 4 equations, and in each equation, they're just one step. We just see that x is being cubed and it's equal to a number. So I'm actually going to rewrite my list of perfect cubes. We had 1 cubed was 1, 2 cubed was 8, 3 cubed was 27, 4 cubed was 64, and 5 cubed was 125. Okay, so I'm going to follow my steps from the previous slide, and the first thing that it said was to rewrite the equation. So we have x cubed is equal to 8. Then we need to undo the cube. So we're going to cube root each side. Make sure you write that little 3 in there. The cube and the cube root symbol get canceled. We're left with x is equal to, and again, if we look up to our list, 2 cubed was equal to 8. So the cube root of 8 is going to be 2. And again, we don't need to make this plus or minus. The answer will always match the same sign as the original number that was being cubed. Moving on to the next one, same deal. I'm going to rewrite the equation. X is just being cubed, so I need to cube root each side to undo the cube and the cube root, leaving x all by itself. And the cube root of 27, again, looking up to our list, 3 cubed was 27, so the cube root of 27 is 3. Next one, get some good practice in here. Rewrite the equation. X cubed is equal to 64. We're undoing a cube, so we need to cube root each side, which cancels the cube and the cube root symbol on x, leaving that all by itself. And now we're doing the cube root of 64, which on our list, it looks like 4 cubed was 64, so the cube root of 64 is 4. Last little practice problem here. I'm going to rewrite the equation just like the previous 3. X is just being cubed, so I'm going to cube root each side, which cancels the cube and the cube root symbol, leaving x all by itself. And then I can see that 125 was 5 cubed. And just note that the 125 underneath this root symbol is negative. And the answer should always match the original number's sign when we cube root. So since the cube root of 125 is 5, the cube root of negative 125 will be negative 5. So that's 4 different practice problems for you there on cube rooting to solve for x. Let's have you give this a try in your first U try. Alright, so I hope you guys are seeing that each of these examples are kind of mirroring the lesson when we did square and square root. Okay, but my second example is now when we're dealing with a fraction. But once again, I want you to notice that both of these numbers are perfect cubes. When you're given a fraction where you're going to have to cube root each side, that's most likely what's going to happen, even though we have not seen this number 343 yet in our list of perfect cubes. And if you're unsure, start generating a list of perfect cubes. Okay, so we had 1 cubed, that was 1, 2 cubed, that was 8, 3 cubed, that was 27, 4 cubed, that was 64, 5 cubed, that was 125. So now start generating some more cubes. 6 times 6 times 6, sorry if that looks bad, 6 times 6 is 36. And 36 times 6, I'm going to do some long multiplication here. See, we have 6 times 6 is 36. And then 6 times 3 is 18, plus another 3 is 21. Okay, so we're getting closer. I'm not quite at 343, but 216 is getting there. So it seems like it's going to be 7 to the third power, 7 cubed. So 7 times 7 times 7. 7 times 7 is 49, so I need to do 49 times 7. 49 times 7. See, 7 times 9, that's going to be 63. 7 times 4 is 28, plus another 6 is 34. So there we go. 7 cubed is 343. Okay, so I'm going to continue my list of perfect cubes. 6 cubed was 216, and 7 cubed was 343. Okay, so now that I see both of those numbers in my fraction on the perfect cube list, I can kind of relax because it's going to be the same problem where we distribute the cube root over the division bar. So I'm going to rewrite my equation. W cubed is equal to 8 over 343. I need to now cube root each side so that I can get W all by itself, trying to solve for W. The cube and the cube root symbol cancel, and I'm left with W. But now I need to distribute the cube root to both the 8 and the 343. Which the cube root of 8 is 2, and the cube root of 343 is 7. So W is equal to 2/7. Positive version only, because again, when we cube root, it should match the original number you're cube rooting. Let's have you give this a try in your second U try. Now, this definitely is a perfect cube, okay? This one is 10 to the third power. That's what this number is under there. 10 cubed is 1,000. So you do have 1, which is a perfect cube. 1 cubed is 1. And you have 1,000, which is a perfect cube. I want you to do the same process and tell me what y has to equal if y cubed is 1 over 1,000. So just like last time, we have another real-life example. We have an aquarium in the shape of a cube, has a volume of 1,256 cubic inches. Now think of what a cube is. A cube is different than just any old rectangular prism. A cube has all of its sides being exactly the same length. Okay, so just like we would have the height, the width, that's a W, sorry. And then the depth or the length, volume is equal to all 3 dimensions multiplied together. Well, a cube has all the dimensions being the same. So really volume is like saying h times h times h, because the width is going to be the same as the height. The length is going to be the same as the height. So volume is really equal to h cubed. Well, instead of calling it height or width or length, I don't want to confuse you from where the side length comes from. It doesn't matter what it is. Let's just call it side. Just like we did with the square when we talked about how a square's area is side squared. Okay, so the volume for a cube that we need to memorize, volume is equal to side cubed. Okay, we're going to use this formula to plug in the 1,256 in for the volume, the V in the volume, and then we're going to solve for S. So I have 1,256 is equal to S cubed, and then in order to solve for S, to figure out what that side length is, we need to cube root both sides. That will cancel out the cube and the cube root on the S, giving me S all by itself. And now, in this particular example, I'm going to allow you to use your calculator. On the test, you're not going to have such large numbers. Plus, I also want you to see where the cube root button is and what the number may look like if you're cube rooting something that may not be a perfect square. So let's take a look at how we would punch this in our calculator. Now, I know I have my computer calculator up, okay, but a lot of times the root buttons or the cube root buttons or even the cube button could be hiding in the second keys, okay? Sometimes they'll label a button right above it in a different color. That means you might have to hit the second button first before you get to it. So like on my screen, I don't see a cube root button. I only see a square root button. But if I hit the second key, then I do see the cube root button. So I'm going to hit that cube root button, and in my computer screen, it like abbreviates it, okay, just without all the vowels. So I see cube root of 1,256. Hit enter, and I'm going to round that, let's say, to the 10th. Let's call this 10.8. And that's actually exactly what my instructions say I need to be rounding to the nearest 10th. So that was 10.8. And make sure you put the units. That was 10.8 inches is the side length of this aquarium. So go ahead and give this a try in your third U try. Again, they're saying this is a cube. So make sure you're just applying the formula that the volume is equal to side cubed. Alrighty, so again, I got one last example for you where we're mixing in the other order of operations. So again, look for addition or subtraction first, then look for multiplication or division, then look to get rid of that cube by cube rooting each side. So that should be your last step. Let's start with the first part here, part A. I see 5x cubed equals 40. So the first thing I'm not seeing any addition or subtraction, but I am seeing that the 5 is multiplying the x. So we need to divide that 5 off first, leaving me with x cubed is equal to 8. Now that I just have x cubed, I can cube root each side. That gets rid of the cube and the cube root on the x, and the cube root of 8 is 2. By this example, I'm hoping you're starting to memorize the first at least 4 or 5 perfect cubes and what their cube roots are. Okay, let's try the second example here. I do see that x has 5 being added to it, so I'm going to have to subtract the 5 to get it to go away. Again, I'm getting rid of any addition or subtraction first. So I'm going to write down the same line, negative 2x cubed plus 5. I'm going to move the equal sign over a little bit so that I can show that I am subtracting 5, because that's the opposite of adding 5, which is what is originally happening. So the positive 5 and the negative 5 go away, and I'm left with negative 2x cubed is equal to, now be careful, negative 49 minus 5 more is negative 54. So now when I look at the left side of my equation, I look at x and I see that the negative 2 is multiplying it. Okay, I got to get rid of any multiplication or division before I can tackle that cube. So since the negative 2 is multiplying x, I'm going to divide that negative 2 off. Make sure you're dividing by negative 2 and not positive 2. Take the negative symbol with it. I want to know what positive x is. So now I just have positive x left over, cubed, is equal to a negative divided by a negative cancels. And we're left with just 54 divided by 2, which is 27. Last step, got to get rid of that cube. So we have to cube root each side, canceling the cube and the cube root symbol. Now I've got x all by itself, and I just need to know what the cube root of 27 is, which is 3. Okay. So 2 more examples now, just incorporating the rest of the order of operations. Sorry, I didn't circle my answer over there. Let's have you guys give this a try in your final U try. Solve for x. All right, I've got 2 more close and check questions for you. I will be checking over your responses when I grade your ed puzzles, so please make sure if you don't understand what the question is asking you, get some help. Or if you need any help phrasing your response, because both of these say you need to explain, they're going to be open-ended questions. Raise your hand and ask for help, and I'll make sure you can get your thoughts organized into your sentences. Go ahead and give these a try. All right, so that wraps up our learning target of solving equations with cube roots and square roots. Square roots we tackled in the previous lesson, cube roots we got today. We did this by first simplifying and memorizing the first 4 perfect cubes. We did that in examples 1 through 3. Okay, I made sure that I wrote out the list multiple times for you guys to help you memorize. We also solved equations with cube roots. We actually used cube roots themselves in all the examples again. And then lastly, we did solve for real world problems. That was our example 3 when we were talking about the aquarium. Okay, so please make sure you go back and rewatch any sections you may not have understood or get any help. Make sure you raise your hand and ask any questions. You can now go on to the Google form. Have a great day.